In this video, I'm going to solve this non-homogeneous second order differential equation using the variation of parameters. And this is my differential equation. The way the variation of parameters work is this. We kind of use the variation of parameters to find the particular solution. Then we find the homogeneous solution and then combine them. That means add them to find the general solution. Now, in order to find the particular solution using the variation of parameters, you first have to solve the corresponding homogeneous equation, then find the Wronskian, and then take the coefficient of the y double prime and use them to find the particular solution using the variation of parameters. So let's go ahead and solve the problem. And the homogeneous portion is y double prime minus 2 over t squared times y is equal to 0. Kind of interestingly note that the solution to this differential equation is y1 is equal to t squared. You can check it. If you take double primes, y1 double prime, you'll get 2, and then you plug in y, you'll get 0. Similarly, the second solution is actually y2 is equal to 1 over t. And again, that could be checked. If you take the double prime of this, you'll get the second derivative and then plug in the value of y here, and you'll see left hand side is going to be 0. So these are the two solutions to these homogeneous differential equations. Now let's go ahead and find the Wronskian of it to make sure that they are independent. Of course, they are independent, linearly independent. That's what I meant. So Wronskian, as you know, is nothing but determinant of y1 and y1 prime in the first column, y2 and y2 prime in the second column, and the determinant of that. If you take the determinant, what do you get? So let's go ahead and plug in the values here. y1 is t squared, right? Derivative of t squared is 2t. y2 is 1 over t, right? And derivative of y2 is going to be negative 1 over t squared. Now, if you find the determinant is going to be negative 1, t squared times negative 1 over t squared is negative 1, then minus 2, which is negative 3. So Wronskian is nothing but negative 3. And by the way, your general solution for the homogeneous part, y sub h of t is going to be c1, some constant, times y1, right, which is t squared, plus c2 times y2, which is 1 over t. And we are going to use this solution later on to find the general solution. Now, we have kind of all the things that we need in order to find the particular solution using the variation of parameters. So now, the variation of parameters, I'll just use the formula, by the way. So y hat, some people write y hat, but I write y sub p, the particular solution, is going to be equal to, let's see, what do I have? So negative y1 times integral y2 times g of t, all of it divided by a of t times Wronskian integrated with respect to t, plus y2 times integral y1 g of t divided by a of t times Wronskian integrated with respect to t. This is the formula. Now I have introduced a few notations, a few symbols here, and let me clarify what they mean. The general structure for second order linear differential equations is this. So a of t, y double prime plus b of t times y prime plus c of t times y is equal to g of t. Okay? That's what the general structure / format. Now, g of t is the non-homogeneous part. That means if g of t is 0, you have homogeneous differential equation. If g of t is non-zero, you have the non-homogeneous equation. In our case, it's 1 minus 1 over t squared. So very simple. And a of t is the coefficient of the y double prime. In our case, coefficient of y double prime is just 1. So we have all the things that we need. We have y1, y2, and the Wronskian, and now we can plug it in. So y sub p of t is going to be negative y1, so negative t square, y1 is t square, times integral y2 is 1 over t. So we have to be careful in writing this. It's easy to make mistakes. So g of t is 1 minus 1 over t square, okay, times 1 over a of t is 1 over w is going to be negative 3, 1 over negative 3, because w is negative 3. And that's integrated with respect to t. Plus y2, my y2 was 1 over t, right? Times integral y1, so which is t square, times g of t is 1 minus 1 over t square, times 1 over a of t, which is just 1, so 1 over 1 is 1, then 1 over w, which is 1 over negative 3, all of it integrated with respect to t. Y particular, or y p of t is going to be, so now let's go ahead and bring this negative 3 right underneath negative t squared, so that's going to give me t square over 3, and then integral. So let me make sure that I write it properly. So it's going to be 1 over t dt, okay, minus, so all of this multiplied by this, okay, t square over 3 minus 1 over integral 1 over t cube, okay, 1 over t cube dt. So that is the first one. Plus the second one is 1 over t, then let's go ahead and do it, integral t square dt minus integral dt, just simple. This one came out to be, and all of it multiplied by 1 over t, and I just made a mistake. I realized that it should be negative 3 here, okay, because of this negative t 3. That's going to make this positive sign negative, but I will just leave it as it is for now. So y sub p of t is equal to t square over 3 times integral 1 over t dt is just ln of absolute value of t, right, minus t to the power negative 3 plus 1 divided by negative 3 plus 1. So it's going to be positive, okay, 1 over 2 t square. So the next part is going to be negative 1 over 3t, okay, times the integral of t square is going to be t cube over 3 minus integral of dt is going to be just t, and that should be it. So y sub p of t is going to be equal to t square over 3 times ln of absolute value of t, okay, plus t square over 3 times 1, sorry, it's t square, not t cube, 1 over 2 t square, okay. Then this one is going to be negative 1 over 3t times t cube over 3 plus 1 over 3t times t. Hopefully I haven't made any mistake, because it's very, very easy to make mistakes when you write it out. Okay, so that's going to give me t square over 3. Now what cancels out here? This and this cancel out. That's going to give me 1 over 6 minus, okay, it's going to be t square over 9, because t goes into t cube, t square times, right? And then plus this t and t gonna cancel, 1/3, which if I simplify, what do I get? So I just realized that I forgot something. There should be an ln of absolute value of t. So let me just write it out. Ln of absolute value of t here. Okay. So it's going to be t t square over 3 times ln of absolute value of t square over 3 times ln of absolute value of t minus t square over 9 plus 1/3 plus 1/6 is going to be 1/2. So my y particular of t is going to be t square over 3 ln of absolute value of t minus t square over 9 plus 1/2. So remember, our general solution is supposed to be this: y of t is equal to y sub h of t plus y sub p of t. We have y sub h of t, which is right here, c1 t square plus c2 times 1 over t, okay, plus y particular, which is this value right here, which is going to be t square over 3 times ln of absolute value of t minus t square over 9 plus 1/2. So if I write it out finally, y of t, the general solution is going to be c1 t square plus c2 over t plus t square over 3 times ln of absolute value of t minus t square over 9 plus 1/2. So this, by the way, should be the solution to this differential equation. So this is a lot of calculation, so please pay closer attention. If you find any typos or any mistakes in signs, just adjust things accordingly and it should be fine. The main thing that I wanted to convey here is to make sure that you understand the process, the steps involved in using the variation of parameters to solve the problem, solve the non-homogeneous differential equation. I hope that this discussion was helpful. Thank you very much.